Good afternoon, everyone, and welcome to Additive Manufacturing at the service of the defense industry. My name is Raphaël Roche. I am a key account manager at AddUp. AddUp is a joint venture between Michelin and FIV, specialized in additive manufacturing, metal additive manufacturing. Today, we will be talking about the technology that we are providing to the industry and what it can do for additive for the defense industry. We will start with presenting what is additive manufacturing, in what it is called additive, and what means 3D printing metal, and how it can serve the defense industry. So first, what is additive manufacturing? We call it additive as a difference to subtractive, what is conventionally used. We will see that there are 7 different processes and what the additive market represents today. So what we mostly know about processes for creating a metal part is subtractive processes. That's what you see at the upper side of the slide. You start from raw material, you will remove material, and you will get a part that is rather conventional and some waste that you will just have to dispose. We also use raw material. It's slightly different than a big block of metal. And we will use additive process, so we will add it layer by layer or sometimes directly on a substrate. And we will get a part that is optimized to the function. And we will sometimes, depending on the process, you will see, have some remaining material that we will be able to recycle and reuse. Everybody talks about 3D printing. 3D printing, it's actually 7 different processes. I'm not going to go through all of them. At AddUp, we are specialized in 2 processes. The first one is called powder bed fusion, and the second one is called directed energy deposition. We are going to present that later. The additive manufacturing market today, well, not today, in 2021, it was representing 2.5 billion euro. Among those 2.5 billion euros, it was mostly equally, there was an equal repartition between the USA, Europe, and Asia globally. In 2026, it's expected to grow 23% compared to 2021, going up to 7.81 billion euro. You can see here on the right side the repartition between system, so sales of systems, of machines. You have sales of material, so the powder, the wires that are used for additive manufacturing, and also the supply of parts that are additively manufactured. In the defense industry, the growth is expected to be for additively manufactured parts much higher than the 23% that we saw. So the part that is held by the defense industry in the additive market will grow tremendously. As you can see in Europe, going from, in 2022, 24 million euro to 156, and the growth is almost equal in the USA. It has been identified, additive manufacturing, as a very key technology by all governments. I have here some example. So it's a strategic technology. It's seen as a vector for performance. It's seen as a technology of sovereignty for the countries. And it's supported by most governments. Here you have the European Defense Fund that invested more than 60 million euros in projects for additive manufacturing. It's part of the France Relance program. It's a very known program that aims to increase the competitivity of France in 2030. There is a specific channel that has been created and in which projects can be started. And most recently, the President Biden has announced the AM Forward program that also aims at developing additive manufacturing. But what does it mean to print metal? So we focus on the PBF, powder bed fusion, and DED, direct energy deposition technologies. We will see that it's an industrial process, And you will see that you can get very good mechanical characteristics with, this, with those processes. What is powder bed fusion? Basically, with powder bed fusion, you will spread some powder on the platform. You will melt selectively a surface. This platform will go down. You will spread another layer of powder, melt again, and layer by layer, you will obtain a part that will be surrounded by powder, and you will remove the powder around and extract your part. In our machines, you can have up to 4 lasers that are working on the melting at the same time. The part size in our machines can be up to 350 times 350 times 350 millimeter. We are working on machines to go further and get and make bigger parts. And this technology is rather made for precision and serial production of parts. Then we have the DED technology. That's the one that is displayed on the right side. Okay, or which is not displayed on the right side. Okay, I'm going to explain it this way. So you have like a 5-axis machine in which you have a head. In this head, you can see it here, you will have some powder that will be conveyed, and this powder will be melted by a laser that is at the center of this head. This will allow you to add some powder and add some material on top of an existing part. So the part size can be up to 1.2 meter times 800 times 800 millimeters. So you see it's bigger parts. And this is more made for repair of existing parts and adding functions to existing parts as well. Very often, when people who don't really know additive manufacturing come to us, they are very surprised because they expect to be received in a garage where a small machine is at the corner in a dirty environment. They really think it's like, you know, this crazy engineer working in crazy conditions. This is not what it is at all. We are a very industrial company. Actually, the 2 shareholders of our company are very industrial and have a very big past and strong past, strong history of industry. We work under controlled environment. We avoid any kind of cross-contamination. We ensure the best conditions for the machines to operate. And of course, operator safety is at the center of everything. You work with powder, you need to be careful. There are risks of inhalation, of explosion. So everything needs to be under control, and that's how we operate, and that's the conditions that we recommend to our customers who are using our machines. Also, when we talk about working in series and creating serial conditions, we need to monitor. We need to ensure that what is happening in the machine is what we expect to happen, and so we can ensure that the parts that will be placed inside vehicles are safe and are going to perform as we expect them to perform. So for this, we provide 3 levels of monitoring. It's just to show you how industrial this all is. Our machines have more than 100 sensors inside, and we can monitor them in real time after the production, and we can also have some alerts in case some values would deviate and the production would be jeopardized. We have a second level of monitoring. This is ensuring that the powder is always well spread. If the powder wouldn't be well spread, you could have holes inside your parts, and you of course don't want that. So that's what we call the layering monitoring. And we have the last level, we go really micro, we monitor every melt pool. So you can see what is happening in every melt pool that are made inside your part. And after the process, you can actually compare what you obtained in your production to what you were expecting to do. All this is great, but going through all this data can be very painful, so we can also build comprehensive reports that just tell you if your part is okay to be mounted in the vehicle or not. Mechanical characteristics. Additive manufacturing is great, but if it cannot perform as good as conventional manufacturing, That would be a pity because we couldn't use it. Here I'm not going to go through every table. Just for you to know, the gray bars are casting, the dark gray bars are forging, and the purple ones are 3D printing through powder bed fusion. So just to show you, in terms of mechanical characteristics, we are always superior to casting, and we are very often very close to what forging provides. So now, how can additive manufacturing serve the defense industry? So we will see that with additive manufacturing, it's not everything magical, but you have some freedom compared to conventional manufacturing. It can help solve the obsolescence issue that is very often seen in the defense industry because of the long programs and everything you know already. It's also a solution to shorten the supply chain. I think the recent event showed that supply chain can be really a pain point if it's not mastered. And I will show you some case studies. So freedom of design. It's a new technology, there are new rules. So depending on the technology we are using, either powder bed fusion or direct energy depositions, there are some rules to respect. But as you can see in the parts here, you actually have new possibilities. We see channels that are internal, we can reduce assemblies, we can do lightweight parts like this one. So we stop thinking with the conventional tool we have. We actually start to think function. Okay, what does my part need to do at the end? Which efforts it needs to resist? And thinking like that, we can really optimize the design in order to get a function and not too much weight or not too many parts that are long to produce. It offers a lot of possibilities. It also solves the issue of obsolescence. In the defense industry, there are a lot of challenges. Product life cycles are pretty long. There are operational system developments, technology refreshments because of those long programs, and logistics performance is a key point. 3D printing allows solutions to all those points. Basically, we can produce parts without stocks of toolings or components. You do not need to keep your molds for 30 years in order to solve an issue that could happen maybe 20 years later. You can also follow design evolutions. So if a product needs to be improved, you can instantly change your design and produce it. You can design to performance and not design with the tools that you actually own. And you can print on demand. The solution to shorten the supply chain can be doubled. You can print on demand, like I was saying, so you start from a need. You can transfer a file if you own a file, but if you don't own a file, you can just send a part, and we can take care of scanning the part and prepare the data. Then we will process to the production and the production of your part thanks to our machine. Then there is very often a post-processing, for example, for the functional surfaces that you need to adjust to have the right tolerances. You would control and send the part. So that's a very short chain that is allowed by this process. You can also print local. So we have a product that is called the FlexCare. That's this container that you see here. It can actually be many containers that you would put together, and it is transportable by truck, and you can directly place a machine in there. It has all the perfect operating conditions to print on site. So the idea with this would be to print directly on operational ground. This is not only a concept, it already exists in France, it's Cinnabol in Paris. It's a key-end solution. Basically, we just deliver your machine and your facility. And now I have two case studies to show you. This first one was solving an obsolescence issue for the French Navy. So you have this scraper here. It's an oil scraper. It's placed on a battleship. It's placed on the transmission line, so it's a quite important part. If it fails, the ship cannot continue its way. So the part was faulty, and they had an issue of obsolescence. No CAD file, no drawing, nothing. So basically, they sent us the part. We scanned it. We reconstituted the model, and we produced it. Then we compared. To the first part to see if the dimensions were correct, and it was replaced inside the ship. This part was operational for months, so it passed the first step of qualification. It's currently passing the second step, and this part will be referenced in the French Navy to be provided, to be supplied directly through additive manufacturing, and not to with the former manufacturing means. And the best in this story is that not only it solved an obsolescence problem, the part had a similar cost to the conventionally manufactured part, a similar performance, and the lead times was like 20 times faster than conventional manufacturing. We have a second case study. That's something that we developed with Arcus. You have here on the left a suspension arm, which was conventionally manufactured, and it was redesigned for additive manufacturing. The result that you see on the right is lighter, is stronger, it's smarter, and it's repairable. This was a hybrid part. So the gray part of the part that you see here was made with our powder bed fusion technology. And the green branches that you see, they were added with the DED technology. So this was aimed to show how we can repair parts on site. So we would have additionally manufactured parts, and if they would fail on site, we could repair them directly with the DED process. Lighter, so we saved 400 grams through topology optimization. Stronger, the weak areas that we used to break easily, they were reinforced through additive manufacturing. Smarter, we actually integrated a new function. There is in this part a channel in which you can put a pipe, and repairable through the DED process. I have here a short video. I hope this one works to show you what the DED process. Yeah, so you see how it works. Here you have this head I was mentioning. The part is placed inside the machine, and we add layer by layer, melt pool by melt pool, some material until the part is finished. And actually, I have invited to this conference Myrti, who is from Arcus, and she was the project manager for this part. Yeah, if you have any question about this part, you can ask them to Myrti directly later. And the part is actually seeable on the Arcus booth. You cannot miss it. It's right in the middle where all the additive manufacturing parts are displayed. I thank you very much for your attention. You can meet us at AddUp. We are on the Michelin booth. It's in Hall 6, booth K71. And if you have any question for me or for Myrti, we would be very glad to answer them. No question or too many questions? I don't know what is, if it's a good sign.
Let me add a few words. So we are Arcus. We are not linked financially or anything with AddUp. We just choose what we thought the right manufacturer for us. We are very happy with the result. Please come and see for yourself. It's incredible. The precision, it's really impressive. We are all 5 F218. Please judge with your own eyes. And really, you did an amazing job.
Okay, so thank you. Have a good evening.